Morning, students. So today's topic is types of network and network topology. Let's start with the first topic. The first topic is the types of network. A network consists of two or more computers that are linked in order to share resources such as printers and CDs, exchange files, or allow electronic communication. The three major types of network designed to operate over the area they cover that are: the first is LAN, it is local area network. The second is MAN, metropolitan area network. And the third one is WAN, the wide area network. We have the three different types of networks that are available. First of all, what is network? As we discussed in the previous lectures, whenever we are going to add more than one system, it is called a network. Suppose we have a 10 systems, we can add these systems with each other to make the networking in between them. This is called a network, a computer network. Now we have the three different types of networks, but they are depends upon the area they are covered. Depends upon the area they are covered. They can categorize the types of network into the three categories. The first is local area network. Second one is metropolitan area network. And the last one is wide area network. Let's start with the first one, that is called the local area network. LAN or local area network connects network devices in such a way that a personal computer and workstations can share data, tools, and programs. The group of computers and devices are connected together by a switch or a stack of switches. Stack of switches means a multiple switches using a private addressing scheme as defined by the TCP/IP protocol. Private addresses are unique in relation to other computers on the local area network. Routers are found at the boundary of the LAN, connecting them to the larger WAN that is called wide area network. So what is the meaning of local area network? It means, it, as the name implies, it covers the local area. It covers the restricted area. The Whenever we add the number of systems, why we add the number of system in between them? For sharing the data, tools, and the programs. And the group of these computers or devices, they are connected with each other with the help of switch. Basically, switch is a networking equipment device. With the help of switch, we are able to add more than one system easily. And sometimes we are using the number of switches. That's why it is called the stack of switches. And in this network, we are using a private address scheme that is defined by the TCP/IP. What is TCP/IP? TCP is the transmission control protocol, which is restrict to require the transmissions of the data from one device to the other device. And IP protocol is the internet protocol. We all know whenever any system that is on the network, it has the unique IP address. And what do you mean by the private addressing scheme? Private addressing scheme means we are assigning the subnet mask or the sub addresses to the number of systems which we are going to add in the network. What it means, whenever we are adding the, suppose we are going to add the 10 different systems. So what it means, we have the unique IP address of single system. Now we can divide that particular unique IP address into the multiple addresses, and that multiple addresses can given to the number of systems that are the part of that network. And sometimes we also use the routers. Why we use the routers? They can write that routers can be used at the boundary of that network, means at the outskirts of that network. So what it means, why the router is at that place? Before discussing this, we have to know what is the working of router. Basically, router gives the path to the packets for the delivery. What it means, suppose I send some data towards you. I am sitting on the system number 1 and I am sending the data to the system number 10. We have the number of paths that are traveling from system 1 to system 10. Now it depends upon the router to decide the particular route to which the data packets can be followed. So that's why we are using the routers. This is all about the local area network. And now we have the diagram. Look at the diagram is there. They have the number of systems, the number of systems, and they are connected with a single device, or you can say a server. They are connected with the server, and these devices can be connected with each other. Now, whenever, suppose, look at your screens. Suppose I am sending it here at this system. Now I am going to send the data to this particular system. So what is the route? First, the data can be goes at this point. The centrally point is there. Now they can route the data towards to the this system. So this is all about the local area network. Clear? This is the first type of network, that is called LAN, or you can say local area network. Okay, the next topic is second type of network is MAN, M-A-N, MAN, that is called Metropolitan Area Network. MAN or Metropolitan Area Network covers a large area that than of the LAN and smaller area as compared to the WAN. What it means, it covers the large area as compared to the LAN. LAN is the local area network. I just gave you the example. Suppose I want to make a network in our lab that comes under the category of local area network. Suppose now we are going to create the MAN. What is MAN? I just give you a single example. We have the number of labs in our college, and we want to connect all the labs in a single network. Then we use metropolitan area network. Clear? That the area of the MAN is greater than the LAN, but smaller than the WAN. It resides in between the local area network and wide area network. It connects two or more computers that are apart but resides in the same or the different cities. That are apart. Apart means physically they are at the different locations, but they are reside in the different cities. So it means, suppose some of the systems they are available in the Amritsar, and some of the systems they are available in the Jalandhar, but we can easily link these computers with the help of metropolitan area network. Automatically, there is a big difference between the Amritsar and the Jalandhar. So they can cover the large area as compared to the local area network. So this is called the metropolitan area network. It covers a large geographical area and may serve as an ISP, that is called Internet Service Provider. ISP means the company name which provide you the internet services. Internet service provider. For example, you have the different number of connections. Some of the students they have the Geo connection, some of the students they have the Vodafone connection, some of the students they have the Airtel connection, but they are using the internet. So Airtel, Vodafone, Geo, they all are the internet service providers which can provide the internet services to the users. Clear? MAN is designed for customers who need a high speed connectivity. What it means, the speed connectivity is high in the case of MAN as compared to the LAN. Speeds of MAN ranges in the terms of Mbps, that is called megabits per second. The speed that is calculated in the case of MAN, that calculated in the terms of Mbps, that is called megabits per second. It's hard to design and maintain a metropolitan area network. As compared to the local area network, always it is hard to design a particular network and maintain that network. Why? Difficult to design and maintain because the geographical area is very large. We have to connect all the systems at the same place and maintain these networks, because the systems they are belongs to a different areas. Some of the systems they are reside in the Amritsar, some of the systems they are reside in other cities, and we have to maintain the link in between them. That's why it's difficult to design and maintain as compared to the local area network. Clear? And this is the example. Look at here, the MAN is there, that is called the metropolitan area network. Now The simple example is, look at the first, the local area network, the local area network, the local area network. What it means, we have the different local area networks, and whenever we combine these local area networks into a single unit, that becomes the metropolitan area networks. Clear? I just give you the another example. In the case of LAN, we take the example of our computer lab. Suppose we are going to make a network in our computer lab. This is called the local area network. We have the 10 different labs, computer labs in our college. All the 10 different labs, they have the local area networks in their labs. But when we want to join all the 10 different all the 10 different labs into a single network, then we can combine all the local area networks that are present in all the 10 different labs and maintain a new network that is called Metropolitan Area Network. Clear? So this is all about the metropolitan area network. Okay, so the last is the WAN. WAN is called the wide area network. As the name implies, the wide area. Wide means a large area. It can cover the large area over the geographical areas. Clear? WAN or the wide area network is a computer network that extends over a large geographical area, although it might be confirmed within the bounds of a state or a country. So what it means, whenever we have a network who covers the every state or the including the complete country, that is called the wide area network. And the best example of the wide area network is internet. Internet is available throughout the world. Either you are in India, either you are in Australia, England, Germany, anywhere in the world, you are able to access the services of internet. So this is the best example of wide area network. A WAN could be connection of the LAN connecting to the other LANs via a telephone lines and the radio waves, and might be limited to an enterprise or accessible to the public. The technology is high speed and relatively expensive. Now they can we have the two different methods to apply the WAN. The first is to combine the different local area networks with the help of telephone lines. If somebody having a internet connection in their home, you can say the telephone line that is coming from the telephone exchange that directly comes into your home and plug in into the modem, and you can apply that particular cable that is connected to the modem to your laptop. So the two ways are from where the network is available to you. The first is from the telephone lines, and the second one is radio waves. Radio waves is that is available in your cell phones. Your cell phones can receive the signals. There is no wire in the cell phone. You can receive the signals. You are access the internet, and anywhere you are moving from here to there, but the net is continuously available on your systems. So this is the best example of wide area network. Clear? Uh, so this is the diagram, the wide area network. This is a network where the WAN is there. Look at your screens, the WAN is there. They can show it like a cloud. This is called the network. And then they have the different local area networks. Basically, we can combine the number of local area networks with the other number of local area networks. Now look at here. We have the LAN switch, network uses, network senses, gateway, routers. These all are the networking equipments. Whenever we are going to make a network, whenever network means we are going to add more than one system. So we require the number of devices, number of networking devices to combine to make a bigger network. So this is all about the wide area network. Okay, the next topic is the network topologies. What is network topology? Geometric representation of how the computers are connected to each other is known as topology. There are the 5 different types of topology: the mesh topology, star, bus, ring, and hybrid. Clear? So what is topology? We all know what is a network. It is a network topology. Network means whenever we have the more than one system that is connected with each other. Now the topology is basically, the topology is the physically how the systems can be connected to each other. I just give you the example. Suppose I'm going to add the 5 systems. The first method is we can arrange the system into the single bench in the serial order and make a connection in between these systems. This is a physical architecture of system. And second thing is I have a round table. I placed all the system in the round shape, make a connection of this. This is also a different physical architecture of systems. So what is topology? Topology means the physical architecture, or how physically the place of the systems. Of which systems? The systems which we are going to be connect. Suppose I'm going to be connect a 50 system. You see the number of labs. Some of the labs they have in the serial orders. Some of the labs they have the round shape. Some of the labs they have in the square shape. So the shape, basically how the physically systems they are placed in a network, this is called a topology. Clear? So in our syllabus we have the different 5 types of topologies and the computer network. Look at the diagram, the types of topologies there. The first one is mesh topology, second is the star, then bus topology, then ring topology, then hybrid topology. Now we are going to discuss one by one all the topologies. Let's start with the first one. The first is mesh topology. In a mesh topology, each device is connected to every other device on the network through a dedicated point-to-point link. When we say dedicated, it means that a link only carries a data for the 2 connected devices only. What it means? What is a dedicated link means? Dedicated link means a particular link that is defined in between the 2 systems. A single link, only that link is in between the system 1 and system 2. And suppose a new device is connected, now a different link or different connection from the system to the system 3. This is called the dedicated link. Each device in this topology, each device is connected to other different devices through a dedicated point. For example, just look at this. I just give you the example. Suppose I have the 5 systems in our network and we have a mesh topology. So what it means, and the names of these systems are 1, 2, 3, 4, 5. Okay. Suppose at system 1 is connected with the remaining systems are 4. System 1 is connected with a different link with the system 2, and a dedicated different link with the system 3, a dedicated different link with the system 4, a dedicated different link with the system 5. So what it means, if the 5 systems are there, system number 1 they required 4 links to connect it to the 4 different systems. Clear? Let's say we have n devices in the network, then each device must be connection with n-1 devices. N-1. Now we have to take example. N is equal to, suppose n is equal to the 5. We have the 5 devices. What are the remaining connections are 4. N-1, 5-1, that is 4. Clear? Number of links in a mesh topology of n devices would be the n-1 divided by 2. Why? Because 5 minus 1 divided by 2. 5 minus 1, 4. 5 into 4, 20 divided by 2, that is 10. And if we have the 5 devices, one device is required the 4 by 3 into 2 plus 1, that is also value is equal to the 20, and divided by 2, the value is 10. Or simply we can say, if we have the 5 devices, single device required a 4 dedicated link. Suppose if we have the 10 devices, every device required a 9 different links. If we have the 100 devices, every device required a link of 99 links. Clear? This is all about the mesh topology. And we have the diagram. And look at this. Look at on your screens. This is a system. 5 systems are there. One link is with this system. 1, 2, 3, 4. Every device, you can take any device. These are the systems. 5. You can take the example of any system. The 4 wires are connected to the single system. Look at here. At this 1, 2, 3, 4. Or you can take the example of this 1, 2, 3, 4. You can take the example 1. This is a 1, 2, 3, 4. What it means, every device they required n minus 1 links, and n is the total number of systems in your network. Clear? Now, the advantages of mesh topology: no data traffic issue as there is a dedicated link between the two devices, which means the link is only available for those two devices. No data traffic. Why the no data traffic is? Look at there. Suppose this system want to send the data to that particular system. They have the dedicated link. They are not waiting for the other links to send the message. They have the different links. They can send the message at any time. Mesh topology is reliable and robust as failure of one link doesn't affect other links automatically. If we have the 4 different links, suppose one link is halt. Halt means one link is stop working. Still they have the 3 different links. Suppose 2 links are stop working, but still they have the 2 running links are there. Clear? Mesh topology is secure because there is a point-to-point link. Thus, unauthorized access is not possible. They have the dedicated links are there. So what it means, only look at the diagram. If this system, the first system, this system want to send the message to that particular system, this link is there. Look at there. This link is there. What it means, this link is only in between this system and this system. So unauthorization access is not there. And last one is fault detection is easy. If any fault is there, we can simply detect that fault because they have the dedicated links. Clear? So also we have the some disadvantages. Now let's discuss the disadvantages. Amount of wires required to connect each system is tedious and headache. Yes, we know every system required the 4 wires. We have the 5 systems. Every system required the 4 wires. 5 into 4, 20. We have minimum 20 wires required if we want to make a mesh topology, and that is very difficult to maintain the 20 wires. Clear? Since each device needs to be connected with other devices, number of input output required must be huge. Yes, look at here. At this system, they have the 4 wires. What it means, at least it requires a 4 connections through which the 4 different wires are connected. Clear? Now next, scalability issue, because a device cannot be connected with a large number of. What is scalability? Scalability means whenever you want to add a new device in your system, scale in and scale out. Scale out means whenever we want to grow up our network, and whenever we want to shrink our network, shrink means we want to remove any devices from our network, it is called scale in. And what is scale out? Scale out means whenever we want to grow our network, we want to add some number of devices with our network. So this is all about the mesh topology. Clear? Okay, the next topology is the star topology. Now, as the name implies, star, it looks like a star. In star topology, each device in the network is connected to a central device. Now, this is a difference between the mesh and the star. In mesh topology, every system is connected to every remaining system with a dedicated link. But in the case of star topology, every system that is connected to a single device, and that single device is a central device, that is called hub. Unlike mesh topology, star topology doesn't allow direct communication between devices. No direct communication is there. If any system wants to communicate with other system, the message can be traveled through the hub, because every system is only connected to the hub. First, the message is received by the hub, then hub sends the message to the desired system. Clear? And a device must have to communicate through the hub. If one device wants to send the data to the other device, it has to first send to the data to the hub, and then hub transmit the data to the designated devices. Look at the diagram. This is a star topology. Now you can come to know the difference between the star and the mesh. This is a star topology. The first difference is, and the main difference is, that every system, they only have a single link. With the help of this single link, they are connected with the single device that is called the central device, and that central device is hub. Suppose, look at this, your screens. This system wants to send the data to any system. So what will happen? First, it sends the data. That data can be received by the hub. Now the hub can send the data to the defined system. So this is the working of star topology. Now we have the advantages of star topology. Less expensive because each device only need one input output device. Only a single wire is there. Look at the diagram. The single wire is there. So they only required a single device. The difference between the star and the mesh is star simply means every device. Look at the in that definition. In star topology, each device in the network is connected to the central device that is called the hub. No direct dedicated links are there. Look at the diagram. Every system that is a part of this topology, they can directly communicate with the hub. Suppose if one system wants to send the message to the other system, first the message is received by the hub. After receiving the message by the hub sends the message to the defined system. Clear? So advantages, first is the less expensive, second is easy to install, because we if we have the 5 systems in our star topology, we only required 5 wires. Less amount of capable required, amount of cables are required, because if we are using the mesh, we require the 20 cables. Same 5 systems, we are using the star topology, we only required the 5 cables. Robust, if one link is failed, other links will work just fine. It is also a robust means if the one link is failed, but the hub can continues working. Each fault detection, easy fault detection, because every system connects with the hub. If hub sends the message, we come to know that connection is working. If hub is not able to send the connection to any system, we come to know that that system is not working. Clear? These are the advantages. Also, we have the disadvantages. First, if the hub goes down, everything goes down. This is the major disadvantage, because every system that is connected with the hub, suppose if hub is stops working, the complete topology stops the working, because each and every system that is depends upon a hub. This is the first disadvantage. Second, hub requires more resources and regular maintenance, because it is a central system of star topology. We required a regular maintenance of hub. Why? Because complete star topology that is depends upon hub. If hub stops working, the star topology stops working. Clear? So this is all about the star topology. Okay, the next is the bus topology. In bus topology, there is a main cable and all the devices are connected to the main cable through a drop lines. There is a device called tab that connects the drop lines to the main cable. As the name implies, the bus. We all having a seen a bus. A bus is a straight in the mode, and number of seats are one after the other. Same in this case, we have a bus topology. The bus topology, we have a straight line. That line is a cable, and all the different systems they are connected with that cables through a drop line. And that drop line where we required a device to add that system with that cable. That device name is tab. We required a tab to connect all the systems with the particular single cable. Since all the data is transmitted over the main cable, there is a limit of drop lines and the distance a main cable can have. Now, all the systems they are connected with the main cable, so we have a number of limit is there of the drop lines. Means we are restrict to add the number of devices with the particular cable. So look at the diagram. Look at the diagram. This is a cable. First, you see the cable. The cable is there. These are the systems. We have the different system. This is a drop line. Drop line means a line or a wire which connects a system to that particular cable. And that particular line is connected with the cable with the help of tab. We required another device is there that is called a tab. Clear? Next, okay, we have the advantages and disadvantages of bus topology. First, advantages, easy installation. Why the easy installation? Because we required a single cable and we required systems. They have the drop line and they have the tabs. And the second, the less cables required. Why the less cables required? Because they all are belongs to a single cable. Now we have the disadvantages. Disadvantages, the first is difficult in fault detection. Now look at the cable. Now look at the diagram. Why the difficult to find? Because they all are based on single cable. If anything, any fault is appear, it's difficult to find where the fault is there, because all the systems, they are based on single wire. Clear? Are not scalable, as there is a limit of how many nodes you can. This is not a scalable, as we discussed in earlier. Because why? Because the limit to add the number of devices in a bus topology, that is restricted. For example, we are using the particular wire and the limit of that wire is we only add the 10 different systems. So what it means, in this particular topology, I am only able to add the 10 system. If I'm trying to add the 11th system, I'm not able to do this because the restriction is there. So this is all about the bus topology. Okay, the next is the ring topology. In ring topology, each device is connected with the two devices on either side of it. Why the two devices? Because they act as a ring. Suppose you make a ring. Now you are connected with two devices. First, one is in the right side and one is in the left side. Same with the systems. We make a topology as shape as a ring. So every system is connected with the two sides, right and left. There are two dedicated point-to-point links a device has with the devices on the either side. Now, each device, listen carefully, in a ring topology, each device, they have two dedicated links, one at its right side, one at its left side. Clear? This structure forms a ring that is known as ring topology. Now, this structure makes a ring, a round shaped ring is there, and that's why it is called the ring topology. If a device wants to send data to another device, then it sends the data in one direction. Each device in the ring topology has a repeater. If the received data is intended for other devices, then repeater forwards the data until the intended device receives it. What it means? They have a repeater over there. Suppose there is a ring of 10 systems. Suppose, and the numbering are 1, 2, 3, 4, 5, 6, 7, 8. Okay. I am at the system number 5. Now I am connected with two systems. At right side, system number 6. At left side, system number 4. Clear? I want to send the data to the system number 8. So what it means? We have a repeater in the ring. I sends the message to the system number 6. The message is received on the system number 6. Repeater calculates the address. The address is mentioned on the system number 8. So what it means, now it move forward to the next system. Next system name is system number 7. Address is not matched. Then again, it moves to the next system, that is a system number 8. At the system number 8, when the address matches, it receives the data on the system number 8. So this is the working of the ring topology. Look at the diagram. Now everything is clear to you. We have the systems. Look at any system. Look at this system. It has the two connections, right, left. Because we make a ring. Whenever you want to send the data, you can send it at the one direction. Automatically, the data can be received on the particular device in the ring topology. Clear? So also we have the advantages and the disadvantages of ring. The first, easy to install. Why easy to install? We only required a small dedicated links on the right side and the left side. That's why it is easy to install. Second, managing is easier, as to add or remove device from the topology, only the two links are required. Now, scalability is very easy. Scalability is, if we want to add the device, simply suppose, look at the diagram. I want to add the device over here. Look at your screens, the mouse is there. I want to add here. What can we do? A simple add the system over there. Automatically, now that particular system is linked with the left side and the right side automatically. That's why add or remove is very easy. Clear? Now we have some disadvantages. Disadvantages, first, a link failure can fail the entire network. Why? Look at the diagram. If the link is failed, what it means, the data is not traveled through that particular system, because if the link is failure over there, that particular system is not able to send the data to the next system. That is the first disadvantage. Second, data traffic issue, since all the data is circulating at the rate. Now we have the data traffic issue because suppose, just take the previous example, we have the 10 different systems. I want to send the data to the system number 10 and I am at the system number 2. What will happen? Data travel from system number 2, then go to the 3, 4, 5, 6, 7, 8, 9, then receives at the 10th point. That's why the data traffic issue is there. Clear? So this is all about the ring topology. Okay, the next one is the hybrid topology. A combination of two or more topology is known as hybrid topology. For example, a combination of star and mesh topology is known as hybrid. Simply, whenever we make a combination of two topologies, that new topology name as hybrid topology. We are going to add any two topologies. Make two topologies, make a connected over there. The new topology is there, and that is called hybrid topology. Now the advantages of hybrid topology. We can choose the topology based on the requirement. For example, scalability is our concern. Then we can use the star topology instead of bus topology. Yes. First advantage is, as we discussed earlier, topology. Suppose we are going to make any topology, but that depends upon the requirements. If the requirements are there, then we go for that topology. Suppose if our requirements are scalability, we required scale in and scale out. In the future, we are going to add number of devices. Then we go for a hybrid technology, and that hybrid technology can add star topology instead of bus, because we all know in the bus topology there should be a restriction of number of systems. Clear? Second, scalable, as we can further connect other computer networks with the existing networks with different topology. Yes, we require scalability. We can add number of devices or we can remove the number of devices. So we have the disadvantages of hybrid topology. The first, fault detection is difficult. Why difficult? Because now it is a combination of two topologies, so it is very tedious to us to find the fault over there. Second, installation is difficult. Yes, it's very difficult, because suppose we make a combination of star and ring. For example, first we have to implement the ring. At second step, we have to implement the star. And third, now we are able to connect star and ring in between them. That's why the installation is difficult. The last is design is complex. So maintenance is very, thus the maintenance is very expensive. Why the design is complex? Because now we are going to deal with the two different designs and we have to maintain the connection between the two different designs. That's why it's difficult and it is expensive. Now, this is the diagram. And look at the diagram. The first one is ring. This is a ring topology. And this one is star topology. They are connected with the hub. Now we are going to make the hybrid topology by the combining both of the topologies. Now the next topology comes into the play, that is called hybrid topology. So this is all about the hybrid topology.